With this video, we're going to look at section 2.2, which is called More Graphs and Displays. And then with this section, these are the objectives we want to learn. We want to graph and interpret quantitative data using stem and leaf plots and dot plots. And then we're going to graph and interpret qualitative data using pie charts and Pareto charts. And then the third and last objective will be we're going to graph and interpret paired data sets using scatter plots and time series charts. So the first one is the stem and the leaf plot. This is a run tool for graphing quantitative data sets. Each number is separated into a stem and a leaf, similar to a histogram, and it still contains original data values, provides an easy way to sort data. So, for example, if you have data 21, 25, 25, 26, 27, all these numbers, so you look at the numbers starting with 2, so that will be the stem, and the leaves will be a 1, a 5, another 5, a 6, 7, 8, and these are the numbers. They're all starting with 2. If you look at the example about constructing a stem and leaf plot, the data set lists the number of text messages sent in one day by 50 cell phone users. Display the data in a stem and leaf plot. Describe any patterns. So we have 50 numbers here. Some of them start with 75. Some of them they start with 40. So if you look at this now, and our job is we want to construct a stem and leaf plot using this data set. The data entries, the lowest one is 17 and the highest one is 148. So we're going to use the rightmost digit as the leaf. For example, for 76, 7 will be the stem and 6 will be the leaf. For 104, the stem will be 10 and the leaf will be 4. So we're going to list the stems from 7 to 14 because the last data is 148. And to the left of a vertical line, for each data entry, we're going to list a leaf to the right of each step. So we have two numbers, 17 and 18. Look at this. If we go back here, we have 117 and 118. So when we are starting to construct the stem and leaf plot, the first one with the stem 1, the leaves are 7 and 8. With the stem being 2, these are the leaves. For the stem being 3, these are the leaves. So similarly, we go all the way from 1 to 14 because last number was, the highest number in the data set was 148. So once the chart is complete, and then when you look at here, you see more density at the top of the chart and the bottom of the chart. So from the display, you can see that more than 50% of the cell phone users between 20 and 50 text messages. Okay, now constructing variations of stem and leaf plots. Organize the data set in previous example using a stem and leaf plot that has 2 rows for each stem. Describe any pattern. So the requirement this time is 2 rows for each stem. And we're going to then describe the pattern. So when they say 2 rows for each stem, so what happens is you decide to list each stem twice. Use the leaves 0, 1, 2, 3, 4 in the first stem row, and the leaves 5, 6, 7, 8, 9 in the second stem row. So since we don't have any data like 10, 11, 12, 13, 14, we don't have anything on the first line, but we do have 17 and 18, so that takes the number here. 20, 23, 24, they go on the first row of stem 2, and then 25 to the 29, they will go on to the second row of the stem 2. So when we modify your stem and leaf plots by creating 2 stems for each stem value, you can notice that by using 2 rows per stem, you obtain a more detailed picture of the data. And then from the display, you can see that most of the cell phone users send messages between 20 to 80 text messages because it's very busy all the way to here. But after like just one person sent 88 messages, one person is just 98 messages, one person is 104 messages. So that's what you can observe from this data set. Now, the second graph we're going to look at is called dot plot. Each data entry is plotted using a point above a horizontal axis. So for the sample data set here, we get one data above 21, one dot above 21. We get two dots above 25 because we have two 25s. And then 26 just shows up once, 27, 28. The ones that we don't have, we just don't put any dots here. We have 236, so we're putting two dots here. And this kind of graph is called dot plot. If you look at an example, use a dot plot to organize the data set in example one, so that number of text messages sent data set. And then we're going to describe any patterns if it is possible. Okay, so this is easier. You just need a big number line, and then you just have to list the numbers from 17 to 148, or you can start it from 15 to 150, and then you just have to put one dot if the number shows up once. But for example, 25, it shows up 3 times, so you just put 3 dots next on top of each other. From the dot plot, you can see that most entries occurred between 20 and 80. So if you look at this interval from 20 to 80, we have a lot of dots, but only 4 people sent more than 100 messages. You can also see that 148 is an unusual data entry. It's like there just one person with very extreme number. When you want to construct a dot plot, you can use technology, the Minitab or StatCrunch. You can just use these two tools to construct your dot plots. When we look at pie charts now, pie charts, they provide a convenient way to present qualitative data graphically as percents of a whole. The circle is divided into sectors that represent categories. The area of each sector is proportional to frequency of each category. So here, what we see is this is a chart which shows the earned degrees in 2019. So we have 1,037 people who earned associate's degree, 2,013 people who are earning bachelor's degree, 188 people just doctoral degree, and 834 people for master's degree. And now, if you want to convert this to a pie chart, how is this going to work? Construct the pie chart using the central angle that corresponds to each category. To find the central angle, multiply 360 by the category's relative frequency. For example, the central angle for associate's degree is 360 times 0.225. Okay, let's see where is this coming from. So we need to see how many total people we have here. So we need to add these 4 numbers. If you add them up, here I want to just add them mentally in my head. This is like 3,050. 3,050. And then these two, they give you a little bit more than 1,000. So 3,000, a little bit more than 1,000. So this total people is like a little over than 4,000. So relative frequencies, remember you need to divide this by the sum of these numbers, which becomes this. This is the relative frequency. Now you need to convert this to an angle value. So you need to multiply this by 360 to find the corresponding angle value for associate's degrees. And you do this for all these 4 categories, then you create your pie chart. Now, You can use Excel for this. And Excel will create this pie chart for you. Now, when we look at the Pareto chart, it's a vertical bar graph in which the height of each bar represents the frequency or relative frequency. The bar are positioned in order of decreasing height with the tallest bar position at the left. Here's an example for this chart. In 2019, these were the leading causes of the death in the United States. And these are the numbers for accidents, cancer, lower respiratory disease, heart disease, stroke. And then we want to use the Pareto chart to organize the data. And then we want to see what was the leading cause of death in the United States in 2019. So this is what we get when we create the chart. From this chart, you can see that the leading cause of the death is 2019 was the heart disease. Also, heart disease and cancer caused more deaths than the other three reasons. Graphing paired data sets. Each entry in one data set corresponds to one entry in a second data set. Graph using a scatter plot. The ordered pairs are graphed as points in a coordinate plane used to show the relationship between two quantitative variables. The British statistician Ronald Fisher introduced a famous data set called Fisher's iris data set. This data set describes various physical characteristics such as pedal length and pedal width for three species of iris. The pedal length from the first data set and the pedal width from the second data set. Yeah. So it's pedal length and pedal width. So as the pedal length increases, what tends to happen to pedal width? Each point in the scatter plot represents the pedal length and pedal width of the flower. From the scatter plot, you can see that as the pedal length increases, the pedal width is also increases. This is called a direct relationship. And then sometimes when one of them is increasing, the other one is decreasing. When one of them is increasing, the other one is decreasing. And then when we look at the time series, data set is composed of quantitative entries taken at regular intervals over a period of time. This is what the time series chart graph looks like. And then we look at the examples for each year. We have the burglaries and we have the robberies. And then to construct the time series chart here, we're gonna make the horizontal axis to be representing the years, and the we're gonna let the vertical axis represent the number of vehicle thefts in minutes. Then we're gonna plot the paired data and connect them with line segments. So this is the year, and this is the burglaries, and then we're connecting these dots. The time series chart shows the number of burglaries remained the same until 2011 and then decreased through the 2019. And that's all we are going to do for section 2.2.